All right, so next page, 26. Find the instantaneous velocity when t equals 4. Based on the feedback I got, I think that's probably one of the things that's okay. Oftentimes they will not use the word instantaneous. Mathematicians are lazy. Like I always say, we're just going to say velocity. If we want average, which we don't want as often, we will use the word average. So instantaneous velocity just says plug that 4 into the velocity equation. Okay, that's not supposed to be a v prime from before. Sorry. V of 4 is this. And again, plug that into your calculator. Velocity is a rate, feet per second, based on the units in this problem. Okay. So what are we doing here? Let's figure out how the velocity helps us to describe the motion of the particle. Work with a neighbor to answer the following questions. Okay, so obviously I'm going to be your neighbor. When is the particle at rest? So what does that mean? Particle at rest means it's not moving, which means its velocity is 0. So I want to take this velocity equation from part C and set it equal to 0. And then we're going to do some algebra. So some pretty simple factoring here. And so the velocity is 0 after 2 seconds and 4 seconds. So always include units on these. You don't want to lose an easy point on like a free response question for not having units. Part F, when is the particle moving in the positive direction? So that's asking, like I mentioned a little bit earlier, velocity is a vector. Velocity is positive, moving right or up. So this question is asking when is the velocity positive. Let's take that factored form that we already had. I want to know when that's positive. Okay, so we've got to go back to like pre-calc. Hopefully this is going to click in your heads what we're doing here. On a number line, put the zeros. And then we pick some test numbers to test out those intervals. So anything to the left of 2, anything you want. Anything between 2 and 4, and anything to the right of 4. You can pick any test numbers you want. So we're just basically breaking the number line into 3 pieces using these zeros here. We're going to plug them in, and all I care about is the sign. So this 3 is always positive. I'm going to ignore that. That's not going to change the sign of my velocity. If I plug a 0 into this first factor, 0 minus 4, that's negative. 0 minus 2, that's negative, and a negative times a negative is a positive. Going on to the 3, 3 minus 4 is negative, 3 minus 2 is positive, and a negative times a positive is a negative. And the 5 would be a positive times a positive, which is a positive. So this tells me that this velocity function is positive to the left of 2, negative between 2 and 4, and positive to the right of 4. So this question was saying when is the particle moving in the positive direction, so we're only going to include the positives. We don't want to include the 2 and the 4 because remember that was where the velocity was equal to 0, and 0 is not positive. So now G, we already have the answer. When is the particle moving in the negative direction? We have it right here, between 2 and 4. So between 2 and 4. And again, we want to include units. So this is an interval of time. So, and that just made me remember we need to get rid of this. We don't want negative infinity. When we're talking about an interval of time, we want 0, right? Time starts at 0. Bracket or parenthesis doesn't matter because we can't include the 0. So from 0 to 2 seconds, the velocity or the particle is moving in the positive direction. And then after 4 and forever, it's moving in the positive direction. In between 2 and 4 seconds, it's moving in the negative direction. So I says draw a diagram to illustrate the motion, and I know that's the, am I skipping something? H, yes I am. At what values does the particle change direction? Oh, that's easy. We already figured that out. Changes direction at 2 and 4. Now, don't be confused by, we did not know that it changed direction back up here when we figured out where it stopped. because the particle could very well stop and continue in the same direction. Just because it stops doesn't mean it turns around. So we need to go through this number line to make sure that it does change direction. So H is, it changes direction at 2 and 4 seconds. And then I is the hardest part, I know. It's drawing the diagram. So let's figure out what's going on here. Now, these are all time values that we figured out. Time is, particle is stopped when t equals 2 and 4. Particle is moving in the positive direction between 0 and 2 and 4 to infinity, etc. We need to find some position values. We need to know where the particle is. So we already found, was it on the last page? We already found the initial position. So let me show you from the previous video. We plugged in a 0 and we got a negative 14 and we started the diagram. So that's going to be useful information. Okay, we found what happened at 1, but that doesn't really matter to us when we're drawing the diagram. We really want to focus on these values we got over here. So I want to figure out what happens after 2 seconds, or where the particle is after 2 seconds and where the particle is after 4 seconds. So I'm going to plug those in to my position function. Okay, so let me grab my phone calculator. Where did I put my phone? Okay, I'm going to make a new video for that.